So welcome to the video lecture series on Introduction to Computer Networks. This is part 4 of our lecture on Ethernet LANs, and we will jump off to the point where we left off. Okay, so we now know that that Ethernet LAN switch needs to maintain a MAC address table, also called a switching table, and it can learn the paths to different MAC addresses through static learning and dynamic learning. So we'll look at 3 different kind of Ethernet frames and the way that a switch would use the information in that frame to forward the frames accordingly. So the first kind is what we call a broadcast frame, and the concept of broadcast is that whenever a switch receives a frame which is of type broadcast, it will then by default broadcast it out to all the interfaces. The way that the frame understands that this is a broadcast frame is by seeing that the destination is set to FF, 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 and like all the hexadecimal digits to F. So this indicates that this particular frame that the switch just received from one of the hosts is intended to be broadcasted in the Ethernet LAN. So when the switch receives this frame, the first thing that it does is that it records the incoming link, because the MAC address table does not really have a record of Alice's MAC address yet. So it records the MAC address of Alice and the interface through which it just received the frame. Next, it sees the destination is set to a broadcast address, which is all F's, and therefore it sends it out to all the other interfaces so that it could reach all the other nodes. The next kind of Ethernet frame is what we call a unicast frame, something that we have seen earlier. So the idea is that this kind of frame is intended to be delivered to a specific LAN device. So for example, if Darcy sends out a frame with Darcy's source MAC address and the destination MAC address of Alice, the switch first checks and sees that Darcy's MAC address is not yet recorded on the in the MAC address table. So it records that is the MAC address of Darcy and the interface that it just received this frame, and then it checks the destination address to be 11, and it finds a record in the MAC address table that this particular MAC address is connected to interface 1. So it now knows the exact interface that it should forward the frame, and it can selectively send it out to Alice. The third kind of frame is where the destination is actually unknown by the switch. So in that case, the switch would also need to flood the frame to every other device apart from the incoming link. So let's say Bob sends out a frame to the switch with the source address of Bob and the destination address of Charlie. So first, the switch checks and sees that it does not yet have a record of Bob's MAC address, so it enters it into the MAC address table, Bob's MAC address and the incoming interface, which is interface number 2. However, next it sees that the destination MAC address is not known and is not available in the MAC address table. Therefore, it will need to flood on all interfaces except for the incoming interface, which is Bob's link. So it sends it out to interfaces 1, 3, and 4. So these examples, what we have seen so far, are rather simple networks where there was only one switch and hosts connected to all the to the same switch. But what if we have a network of switches? Switches can be connected to each other, and each switch can have multiple connected hosts. So let's say in the given network structure, we have 4 switches, S1, S2, and S3. Each of these switches have 3 hosts connected to it, and also these 3 switches are connected to a single switch, S4, all on separate interfaces. So for example, if host A would like to send out something to host G, how would the switch S1 know that it needs to forward the frame through interfaces S4 and S3 to be able to reach G? The concept actually is exactly the same. The forwarding logic that we looked at earlier allows to populate the records in the MAC address table through self-learning and works exactly the same way. So we will look at a multi-switch example where, let's say, we have this current network setup and host A sends a frame to host G, and later then G responds to it. So we will take it phase by phase. The first phase is where A sends it out to G. So first, A sends a frame where the source is MAC A, the destination is MAC G, and is received by switch S1. Below here, you can see the MAC address tables for the switches S1, S2, S3, and S4. So S1 receives the frame from A and sees that it does not yet have a record of the MAC address of A. So it enters it into the table where it has MAC A, and MAC A is connected through interface I2. However, S1 then sees that the destination MAC G is unknown. So therefore, it will now flood it out through all the other interfaces except for the incoming link, which is I2. So therefore, the outgoing interfaces for the flooding would be I1, I3, and I4. So the frame which is forwarded on I3 and I4 reaches B and C, the hosts, they match their own MAC address with the destination MAC address, and when they see that it's not intended for them, they drop the frame. However, the frame which is forwarded through I1 reaches S4. So now S4 looks at the frame and sees that the source is MAC A. So therefore, S4 now knows that if in future anyone would need to reach host A, would need to send it out through interface I1 on switch 4. So therefore, the MAC address table for S4 records the MAC address of A and the outgoing interface as I1. After that, switch 4 checks and finds that the MAC G, which is the destination MAC, is unknown. So now it would need to flood on all the other interfaces except for the incoming link. So it floods it out to interfaces I2 and I3 on S4. So the frame which is flooded through interface I2 on S4 reaches S2. S2 receives the frame from S4, and again it checks the frame and finds that the source is MAC address A and it just received it through interface 1, so it first records the incoming interface and the corresponding MAC address. The destination MACG is unknown to S2, so therefore it will now need to flood on all the other interfaces except for I1. So the interfaces I2, I3, and I4 on the switch S2 would reach hosts D, E, and F. However, the destination MAC address does not match for any of these hosts. So D, E, and F, all of these would drop the frame. So going back to the step where S4 also broadcasted the frame on interface I3, that is sent out and received by S3. So S3 receives the frame from S4 and records the source MAC address, MAC A, and the interface through which it just received that particular frame, which is going to be I1. So S3 puts this record into its MAC address table, and then it sees that the destination MAC address of G is unknown to S3. So it will now need to flood the frame on interfaces I2, I3, and I4. So when the frame is flooded, all the hosts G, H, and I receive the frame. However, H and I, they match the destination MAC address, and when it doesn't match, both of them, they drop the frame. However, when G receives that frame, it matches the destination MAC address and sees that it is a match, so therefore G receives the frame. So now in the next part, if G is responding to A, we have the current status of the MAC address tables. So first, G sends out the frame with the source address of MAC G and the destination address of MAC A to S3. So S3 received the frame from G, and now it sees that the source MAC G is not recorded on the table, and it just received this frame on interface I2. So it records it into the table. After that, S3 would try to match the destination MAC address, which is MAC A, and it actually finds a record of MAC A in its MAC address table, and it sees that MAC A can be reached if the frame is forwarded out through interface 1 on S3. So it forwards it on I1. So when it forwards it out to I1, the frame is received by S4, and when S4 receives the frame from S3, it first checks the frame and sees that the source MAC address of MAC G is not known in S4's MAC address table. So it will record the incoming link, which is interface 3 for MAC G. Next, it checks the destination MAC address, which is MAC A, and finds a record of MAC A in its MAC address table. And it sees that if anyone would like to reach MAC A, S4 needs to forward the packet out through interface I1. So the frame is forwarded through interface I1, and then S1 receives the frame from S4. So when S1 receives the frame, it first checks the frame and sees that the source address of MAC G is not known in its MAC address table. So it includes that record of MACG, and the interface is I1 because this is the incoming link that it just received this particular frame. So it records this entry as MACG on interface I1, and next it checks the destination MAC address. And S1 finds that MAC address of A is known to S1, and it sees that if I would like to reach MAC A, I would need to forward it out to interface I2. So it forwards the frame to interface I2, and that is the actual host which receives the frame from S1.